Here we have a SAT math question. Okay, there is a figure given over here. In the figure above, AD equals to 3, BD equals to 6, and BC equals to 15. What is the area of the trapezoid ADEC? So we have to get the area of this trapezoid ADEC. Okay, so let me write the formula to find the area of a trapezoid. Let me write the stuff over here. Trapezoid ADEC. So if I want to get the area of a trapezoid, what I have to do is I have to take 1/2 times height times A positive B. So here this H represents the height of the trapezoid and this A and B represents the lengths of the two bases. So here the two bases of this trapezoid are DE and AC. Already we know the height of the trapezoid, that is 3. So to get area of the trapezoid ADEC, I must be knowing the lengths of DE and AC. Okay, now to get the length of the base AC, what I'm going to do is I'm going to consider the outer right triangle BAC. So in this outer right triangle BAC, I know the length of this leg BA, which is 9, because 6 positive 3 is 9. And also I know the length of the hypotenuse BC, that is given in the question itself, that is 15. So I can use a Pythagorean theorem in this outer triangle, right triangle BAC, to get the length of the leg AC. Let me write the stuff over here. Let's consider the right triangle BAC. So let's use Pythagorean theorem, that is BA square positive AC square equals to the square of the hypotenuse, that is BC square. So the Pythagorean theorem says the sum of the squares of two legs of a right triangle always equals to the square of the hypotenuse. That's what I have written over here. We know the length of BA, that is 9 square. I do not know the length of AC. We can write AC whole square as it is. We know the length of BC, that is 15 square. So 81 positive AC square equals to 15 square is 225. If I subtract 81 from both sides, I'm getting 144 on the right side. Okay, now to get the length of AC, I have to get up the square. For that, I'm taking square root on both sides. So the square root and square will cancel out. Usually when I take square root on both sides, we have to consider a positive or negative sign for one of the square roots. But here the negative sign will not work because AC represents the length of one of the legs of the triangle. It can never be a negative number. So we get AC equals to the square root of 144 is 12. So now I got the length of the leg AC, that is 12. Okay, now we have to find the length of the base DE. So for that, what I'm going to do is I'm going to consider the trapezoid ADEC. Since it's a trapezoid, the two bases DE and AC are parallel. Since these two line segments DE and AC are parallel, we can consider this BC as a transversal. When BC is a transversal, the angle measure over here, the angle measure over here are corresponding angles and they must be congruent. So now let's consider the two angle measures in the outer triangle A and C. So these two angle measures are congruent to the two angle measures in the inner triangle D and E, because A here is right angle and the angle measure D is right angle, and angle measure at E and angle measure at C are corresponding angles. They are congruent. So the two angles A and C of outer triangle BAC are congruent to the two angle measures D and D in the inner triangle. So by angle similarity postulate, the two triangles, the outer triangle BAC and the inner triangle BDE are similar. Okay, now let me write the stuff over here. So let me take the common vertex. B is the common vertex for both the triangles. So let me take B, and now I take the vertex D in the inner triangle at where we have the right angle. So here I'm taking the common vertex B for the outer triangle. So here the second vertex I have taken at where we have right angle. So in the outer triangle also I have to take the vertex at where we have the right angle, that is A. And so clearly E and C, the angle measure at the vertices E and D are congruent because they are corresponding angles. So E we have in the smaller triangle and C we have in the bigger triangle, I mean the outer triangle. So these two triangles are similar. Okay, now since these two triangles are similar, the corresponding sides are proportional. So using that stuff, we'll be able to get the length of the line segment DE. Okay, now what I'm going to do is, since mine is to get the length of DE in the inner triangle, let me take a DE in the inner triangle first. I have to consider the alphabets are the same position in the outer triangle, that is AC. Okay, now we have to consider another side in this inner triangle. We know the length of BD, so we can take a BD in the inner triangle. The corresponding side in the outer triangle is going to be BA. So the letters we have at the same position to be considered. Let me write the stuff for here. So DE, I do not know the length, but AC, I do know the length, that is 12. We can plug in 12 for AC. And for BD, I know that the length is 6. And for BA, I know the length, it's 9. So here we can simplify the 6 over 9. That is 3 goes into 6 2 times and 3 goes into 9 3 times. I'm getting DE over 12 equals to 2 over 3. So now I have to multiply both sides by 12 to get of the denominator 12 over here. So this 12 and 12 will cancel. 3 goes into 3 1 times, 3 goes into 12 4 times. So DE equals to 2 times 4 is 8. Okay, now I got the length of DE. Okay, now I know the lengths of the two bases of the trapezoid ADEC, 8 and 12. So we can plug in the values. 1 over 2 times the height of the trapezoid is 3, and A is the length of one of the bases. We can consider this 8 as the value of A, and B is the length of the second base, that is 12. So 1 over 2 times 3 times 8 positive 12 is 20. So 2 goes into 2 1 times, 2 goes into 20 10 times. So 1 times 3 is 3, 3 times 10 is 30. So the area of the trapezoid ADEC is 30 square units.